Good day, everyone. Also, good day to Professor Ponsalan and my classmates. We are the sixth group and we will be reporting about the IEC or the International Electrotechnical Commission. Before we proceed, let me introduce myself and group members. I, Zara May Laureles, Mr. John Lester Cesar, and Mr. Ken Carlo Paye. So to proceed, let us tackle first who is IEC. So their vision is IEC everywhere for a safer and more efficient world. And their mission is to achieve worldwide use of IEC international standards and conformity assessment systems to ensure the safety, efficiency, reliability, and interoperability of electrical, electronic, and information technologies to enhance international trade, facilitate broad electricity access, and enable a more sustainable world. And they have four core values that IEC uses as their guide, which is first, being trustworthy, inclusive, independent, and progressive. So who is IEC? IEC is an international electrotechnical commission known as IEC, is a major global organization that develops and disseminates international standards para sa lahat ng electrical, electronic, and yung mga associated technologies. So, itong mga technology na to or electronic is known as a whole as electrotechnology. So, about IEC, IEC is a non-profit organization and an international membership organization na nagbi-bring together ng 20,000 professionals from around the world and are coordinated by more than 170 countries. So, let's dive into the history of IEC. Noong 2nd to 4th Industrial Revolution, alam naman natin na doon nag-emerge yung electricity. And then on the year 1904, meron tayong tinatawag na International Electrical Congress kung saan nag-exhibit sila ng iba't ibang klase ng electricity para bang nag-compare and contrast sila. Example, using different voltages, yung mga single phase, two phase, and three phase. And then, doon nag-decide yung Congress na kailangan nilang magkaroon ng International Commission na sila yung mag-establish ng terms and measurements for ratings of electrical apparatus, machines, and mga devices natin. And then, IEC was founded on June 27, 1906. So, yung first meeting nila is ginanap on Cecil Hotel and their chair is Alexander Siemens, who is a German electrical engineer. Moving on, itakal naman natin yung tungkol sa IEC leadership. So, the General Assembly selects or appoints individual to serve as the IEC officers. And then, yung IEC Secretariat, ayun yung way para para makausap natin yung, or para maging in touch tayo sa mga IEC officers. Next, IEC around the world. From offices on every continent, they serve their stakeholders all around the world. So ngayon, currently, meron silang 7 operating offices around the continent. And lastly is yung mga awards. The IEC recognizes the dedication and labor of the people who each year uses their ability to lead and their technical knowledge have helped enhancing the safety, efficiency, and reliability of electrical products and systems. So meron silang 3 award which are Lord Kevin Award. Ito ay ina-award sa highest IEC tribute which recognizes exceptional long-term achievements. Then, the Thomas A. Edison Award. It recognizes exceptional current achievement of TC and SC and conformity assessment officers. And then lastly is the 1906 Award na nag-recognize ng exceptional current achievements ng mga experts sa IEC. So, what does IEC do? Yung IEC is nagpa-publish sila ng 10,000 IEC international standards with conformity assessment. that provides technical framework na nakakatulong sa government para makapag-build ng high-quality national infrastructure and businesses in different sizes para makapag-purchase sila and sell consistently ng reliable products in the majority of the world's nation. Also, yung IEC international standards natin ay ginagamit din siya as testing and certification para yung mga manufacturer claims ay masusunod. And sila din yung nagsaserve as the foundation for risk and quality management. So, yung IEC, sila ay nag-enable ng global trade. So, most common type ng components and equipments na tina-trade sa iba't ibang part ng mundo is electrical or electronics. So, itong mga bagay na to or group of items na to is malaki and malaki yung halaga and kailangan nito na always siyang secure at kailangan functionable siya in various ways. So, para magawa yon, kailangan na gumawa ng international standards at dito papasok yung IEC kung saan nagpo-provide sila ng mga regulations, international regulations na i-apply globally para mas mapaayos yung trading system. Next is they encourage development. So, yung trabaho ng IEC is para rin makapag-encourage sila na magkaroon ng access to cutting-edge knowledge and technology and then nagsusupport sila ng inclusive and sustainable economic growth. So, yung mga developing nations natin is pwede sila mag-take part in IEC affiliate country programs nang hindi nila kailangan magbayad ng membership fees. Then, ang IEC is nagka-create and nagde-develop ng standards. So, alam naman natin na ang standard is for procedure for performing a task in a reliable and dependable manner which establish the bare minimal criteria para sa safety, dependability, effectiveness, and of course, trust. And then, nagpo-provide din sila ng conformity assessments. So, yung pag-perform ng conformity evaluation is nag-i-involve ng confirming na ang standard natin or yung design, manufacture, installation, and yung other processes all use technical specifications, the upkeep or the repair of machine or system. This action has to be taken in accordance with a set of clear guidelines to ensure consistency and reproducible outcomes. In other words, itong conformity assessment natin is kailangan siya na i-adapt natin sa standard as a defined procedure. Next, what is a standard? So understanding standards, recap lang, alam naman natin na ang standard is repeatable, consistent, recognized, and recorded procedure. Technical specifications or other exact criteria are contained in standards which are intended to apply consistently as a rule, guideline, or definition. So, a standard is widely accepted norm that yung mga tao, businesses, and yung government ay ginagamit para ma-carry out yung isang task, whether it's creating a product, offering a service, managing a process, or dealing with the outside world like yung mga batas natin. Then we have the international standards of IEC. So international IEC standards is very crucial for risk and quality management. In order to design, produce, install, and test and certify, maintain, and repair electrical or electronic systems and devices, nagpo-provide sila ng instructions and guidelines and regulations about dito. Yung international standards are always incorporated into national or regional standards by the nations or other regions. For example, almost 80% ng European electrical and electronic standards are in fact galing sa IEC international standards. And then, meron tayong tinatawag na Standardization Management Board. Yung Standardization Management Board o yung SMB is responsible para sa pag-manage and supervise ng IEC standardization work. The SMB is the decision-making body which report to the IEC board. In other words, sila yung bumubuo ng process ng isang standard, nagche-check, nagre-revise, and then yung IEC board yung nag-a-approve or reject. So, how standards are developed, particularly na yung IEC standards. So, ang IEC standard is developed involving different countries with various experts from different fields such as the industry or yung industrial sector natin, the academic, professional associations, laboratories para sa mga testing, and then, of course, yung public sector natin. So remember that IEC standards cannot reference a standard issued by another organization. Only IEC standards can be referenced. No standard can conflict with another IEC standards. And then no amendments are allowed between revision cycle except for safety issues. And to summarize it all, yung IEC standards natin ay para ma-ensure yung safety and efficiency of devices, systems, or services for people and the environment. So para mangyari yon, according to IEC, first, we must allow products to work and connect with others. Second, make sure that they are used in testing and certification to verify that the manufacturer promises are kept. Then, it should provide technical details in regulations, and last is to facilitate international trade. Now, for the different IEC standards of the International Electrotechnical Commission, starting with Mr. Ken Carlo Paye.
So, good day guys, I'm Ken Carlo J. Paye and let me discuss some of the IEC standards. So, first is the IEC 60027, standard for letter symbols to be used in electrical technology. So this standard is a technical international standard for letter symbols published by the International Electrotechnical Commissions, comprising the following parts: the general, telecommunications and electronics, logarithmic and related quantities and their units, symbols for quantities to be used for rotating electrical machines, control technology, and physiological quantities and units. Then the next standards is the IEC 60034. It is an international standard of the International Electrotechnical Commission for rotating electrical machinery. So, itong standard na to ay applicable siya sa halos lahat ng rotating machines except lang sa mga rotating machines for rail and road vehicles, which is covered na siya ng ibang standard ng IEC, which is yung 06349 series of standard. So the next standard is the IEC 60038, standard voltages. It defines a set of standard used in low voltage and high voltage AC and DC electricity supply system. So dito may voltage na binigay. So bali meron siyang 3-phase na 50 Hz na kung dati yung previous standard ang required na voltages ay 220 to 380 volts, ngayon ay ginawa ng 230 volts to 240 volts for 3-phase 50 Hz dahil nga sa naging updated na yung IEC standards, kaya nabago na siya. So, ginagamit na siya ng mga suppliers ngayon because this migration has already been largely completed, at least within the European Union. So, yung publication na to ay applicable siya sa AC transmission, distribution, and utilization systems and equipments for use in such system with standard frequencies of 50 Hz to 60 Hz. Having a nominal voltage of about 100 volts. So, and also, it's applicable for AC and DC traction system, and AC. And this equipment na may nominal voltage below 120 volts or below 700 to 750 volts DC. So, yung AC voltages being intended apparently exclusively is for 50 Hz and 60 Hz. Applications such as equipments covers batteries from primary or secondary cells or other power supply devices which is for AC or DC electrical equipment including industrial and communication and appliances. So this publication shall not apply to voltages representing or transmitting signals or measured values. Also, it shall not apply to the standard voltages or of components and parts used with the electrical devices of items of equipment. So, the next standard is the IEC 60076 power transformer. So, we all know that the power system is a system of electric energy production, transmission, distribution, and consumption composed of power generation, transformation, transmission, distribution, and consumption. The transformer are extremely important substations equipment in power generation, transformation, and distributions. It is it is transmitted to the place where the power energy is needed through the transmission line, through the transformer. A power transformer is a transformer that converts the AC voltage and current values of the power systems into different voltage and current values of another power systems to transmit electrical energy. The distribution transformer is reduced from the higher voltage to the last level distribution transformer and is directly used as a power transformer for distribution. So, ensuring the safe and economical operations and normal life of transformer and improving their reliability and availability is not only the key to reducing the cost of the power industry, but also the key to ensuring the development of various fields of national economy. So this series of standards falls under the International Electrotechnical Commission's Committee 14 of Transformer, IEC or TC14, the GB-15 1094.1 series of standards are equivalent to the IEC 60076 series of standards but have been modified accordingly. So now the Transformer Performance Parameter Standard na under ni IEC 60076. So yung unang part ay yung general. So dito, applicable siya sa 3-phase and single-phase transformer, including the auto transformer, but excluding some small and special transformer. So for those categories of power transformer and reactors, which have their own IEC standards, this part is applicable only to the extent in which it is specifically called up by the cross-reference in the other standards. So next is the temperature rise for liquid immersed transformer. So ito, applicable siya sa liquid immersed transformer, specifies designs of transformer cooling methods, transformer temperature rise limits, and temperature rise test methods. So itong standard na to is updated na siya. So it includes the following significant technical changes with respect to the previous edition. So the winding hotspot temperature rise limits was introduced among the prescriptions. The procedure for the temperature rise test were improved and in relation to the new thermal requirements. And also, the 5 informative annexes were added in order to facilitate the implementations of these standards. And the next standard is the insulation levels, dielectric test, and external clearances in air. So this specifies the relevant insulation tests and minimum insulation test levels used for transformer applicable to power transformer specified in GB-T1094.1. So this international standard applies to power transformer as defined by the IEC 60076 general, it also recommends external clearances in air. So it gives details of the applicable dielectric test and minimum dielectric test levels, and also this recommended minimum external clearances in air between live parts and between the live parts and earth are given for use, which these clearances are not specified by the purchasers. And for categories of power transformers and reactors, which have their own IEC standards, these standards is applicable only to the extent in which it is specifically called up by the cross-reference in the other standards. So the next parameter standard is the guide for guide to the lighting impulse and switching impulse testing, power transformer and reactors. So this standard is to provide a guideline and make some clarifications to the current methods of lighting impulse and operational impulse testing of power transformers. Then the next parameter standard is the ability to withstand short circuits. So this parameter standard specifies the requirement that the power transformer should be free from damage under the actions of overcurrent caused by the external short circuit, the calculation procedure to characterize the heat resistance ability of power transformer to withstand this kind of overcurrent, and the special test and theoretical evaluation method to bear the corresponding dynamic stability ability. And next is the loading guide for oil immersed power transformers. So this parameter standard is applicable to oil immersed transformer, expound the influence of transformer operation under the different ambient temperature and load conditions on its lives. So this parameter standard also provides guidance for the specifications and loading of power transformer from the point of view of operational temperature and thermal aging. So it provides recommendations for loading above the nameplate rating and guidance for the planner to choose appropriate rated quantities and loading conditions for new installations. And also, this part of parameter standard gives mathematical models for judging the consequence of different loadings with different temperatures of cooling medium and with transient of cyclical variations with time. So these models provide for the calculations of operating temperature in the transformer, particularly the temperature of the hottest part of the windings. So this hot spot temperature is in turn used for evaluations of relative value for the rate of thermal agings and the percentage of life consumed and particular time period. So the modeling refers to a small transformer, here called our distribution transformer and power transformers. So next is the 11th part of the parameter standards that covers the requirements for die-type transformer, enhancing the capacity to support overloads and resistant to short circuits. So this standard is applicable to dry-type power transformer, including the auto transformer, whose maximum voltage is 72.5 kilovolts and below, and at least one winding is higher than 1.1 kilovolts. The dry-type power transformer is suitable for various structures and processes transformer. So, itong standard na to, hindi siya applicable sa mga transformer na hindi nag-e-exist yung standard ng IEC. Tulad ng gas-filled dry-type transformer where the gas is not air, single-phase transformer rated at less than 5 kilovolts ampere. And next is yung fully phase transformer rated at less than 15 kilovolts ampere. And next is yung instrument transformer, starting transformer, testing transformer, traction transformer mounted on on rolling stock, flame-proof and mining transformer, welding transformer, voltage regulating transformer, and the small power transformer in which safety is special considerations. Then also, this parameter standard provides guidance on service condition, rating requirements, trappings, connections, ability to withstand short circuit, rating plate, temperature rise limits, insulation levels, climatic environmental, and fire behavior classes that facilitate the cost-effective setup of dry-type transformer and long-lasting due to a low thermal and dielectric heating. And also, it allows user to develop and assist pollution-free and sustainable dry-type transformer and ensure the safety, performance, and longevity in transformer applications. And the next part of the 60076 parameter standard is the self-protected liquid field transformer. So this standard suitable for indoor or outdoor high voltage or low voltage self-protected liquid filled natural cooling transformer with rated power from 50 kilovolts ampere to 1000 kilovolts ampere, whose primary windings high voltage, maximum voltage is suitable for equipment below 24 kilovolts. And the secondary winding, which is the low voltage, the maximum voltage is 1.1 kilovolts for equivalent below 24 kilovolts. Then the next parameter standard is the liquid immersed power transformer using high temperature insulation materials. So this parameter standard specify the technical specification, design, test, and load information of liquid immersed transformer using high temperature insulating materials or using the high temperature insulating materials and conventional insulating materials that applies to power transformer designed by the IEC 60076-1. Next, next is the gas-filled power transformer. So this parameter standard applies to three-phase and single-phase gas-filled power transformer, including the auto transformer, but does not include some small and special transformer. And next is the transformer for wind turbine applications, which is suitable for dry type and liquid immersed transformer for wind power generation with rated capacity from 100 to 10,000 kilovolts ampere. Maximum voltage of the equipment is not more than 40.5 kilovolts and the working voltage at least one winding is not more than 1.1 kilovolts. So the next is the 220 kilovolts to 750 kilovolts oil immersed power transformer using technical condition standards. So this standard specifies the basis requirements to be followed when using oil immersed power transformers suitable for oil immersed power transformer with a frequency of 50 Hz to 220 to 750 kilovolts. And next is the technical parameter and requirements for 750 kilovolts to 1000 kilovolts oil immersed power transformers. These specify the terms and definitions, operating conditions, performance parameters, technical requirements, test items, test methods and requirements, identification, lifting, packaging, transportations and storage, installation and safety of 750 to 1000 kilovolts single phase oil immersed power transformer, single phase oil immersed power transformer of 750 and 1000 kilovolts rated at least at 550 Hz. And lastly, the combined transformer. So this combined transformer specifies the terms and definitions, conditions of use product, clarifications and product model, basic parameters, technical requirements and test methods, inspection rules, nameplates, signs, lifting packaging, transportations, storage of combined transformer, suitable for oil immersed combined transformer with voltage level of 6 to 35 kilovolts, rated frequency of 50 Hz, and rated capacity of 30 to 25 kilovolts ampere. And I think that's all for my part, and thank you.
Good day, everyone. I'm John Lester M. Cesar, and now we will tackle about the IEC 60083 plugs and socket outlets for domestic and similar general use standardized in member countries of IEC. IEC 60083, the object of this technical report is to give general information about the system of plugs and socket outlets for household and similar purposes which are used in the IEC countries. The report only contains national systems which are commonly used in homes and offices. It is therefore limited to systems for AC with a rated voltage above 50 volts but not exceeding 440 volts, intended for household and similar purposes, either indoors or outdoors. Here are the sample list of plugs and socket outlets which are used in the IEC member countries. Here we can see the picture. It is used by Austria. We can see the rated value of accessory like voltage and current, the number of poles, the diagram of socket outlets and plugs. Next, here in picture in the left, it is used for Belgium, and the right is also used by Austria. We can see the difference between the socket outlets and plugs between the Belgium and the Austria. Next is the IEC 60086 primary batteries. The object of this part of IEC 60086 is to benefit primary battery users, device designers, and battery manufacturers by ensuring that batteries from different manufacturers are interchangeable according to standard form, fit, and function. Furthermore, to ensure compliance with the above, this part specifies standard test methods for testing primary cells and batteries. Next is the IEC 60086 Part 1 2021. General is intended to standardize primary batteries with respect to dimensions, nomenclature, terminal, terminal configurations, markings, test methods, typical performance, safety, and environmental aspects. Next is the 60086 Part 2 2021. Physical and electrical specifications is applicable to primary batteries which are based on standardized electrochemical system. It specifies the physical dimensions and the discharge test conditions and discharge performance requirements. Next is the IEC 60086 Part 3. Watch batteries specifies dimensions, designations, methods of test and requirements for primary batteries for watches. In several cases, a menu of test methods is given. When presenting battery, electrical characteristics, and/or performance data, the manufacturer specifies which test method was used. This publication is published as a double logo standard. Next is the IEC 60086 Part 4. Safety of lithium batteries are specified tests and requirements for primary lithium batteries to ensure their safe operation under intended use and reasonably foreseeable misuse. Note that primary lithium batteries that are standardized in IEC 60086 Part 2 are expected to meet all applicable requirements herein. It is understood that consideration of this part of IEC 60086 might also be given to measuring and/or ensuring the safety of non-standardized primary lithium batteries. In either case, no claim or warranty is made that compliance or non-compliance with standard will fulfill or not fulfill any of the user's particular purposes or needs. Last is the IEC 60086 Part 5. Safety of batteries with aqueous electrolyte specifies tests and requirements for primary batteries with aqueous electrolyte to ensure their safe operation under intended use and reasonably foreseeable misuse. Next is the IEC 60095 lead acid starter batteries. IEC 60095 is applicable to lead acid batteries with nominal voltage of 12 volts, used primarily as a power source for starting internal combustion engines, lighting, and for auxiliary equipment of internal combustion engine vehicles. These batteries are commonly called starter batteries. Batteries are designated according to their type. The first type is the flooded batteries vented. A lead acid battery having a cover provided with one or more opening through which gaseous product may escape. Next is the enhanced flooded batteries. The enhanced flooded batteries with flooded lead acid battery with additional special design features to significantly improve recycling capability compared to standard flooded batteries. Next is the valve regulated lead acid battery or VRLA. Lead acid batteries which is closed under normal conditions but which has arrangement that allows escape of gas if the internal pressure exceeds a predetermined value. Next is the general requirements. Letter A is identification or the labeling. Number 1. General. General batteries complying with this document should bear the following characteristics on at least the top or one of their four sides. Number 2. Identification of manufacturer. The name of the manufacturer or supplier shall be indicated. Number 3. Nominal voltage. The nominal voltage of 12 volts shall be indicated. Number 4. The reserve capacity and nominal cranking current. The identification and labeling for capacity or reserve capacity and nominal cranking current. Number 5. The production date code. Batteries shall be marked with the dates of production. Number 6. Safety labeling. If under national regulations, colored safety symbols are required to be used, they should follow the design. Number 7. The recycling labeling. Batteries shall mark for separate collection and recycling if required by local area regulation. Number 8. The valve-regulated batteries. Valve-regulated batteries shall be marked using the term VRLA. In addition, it is recommended that VRLA batteries shall bear special indication that the battery shall not be opened. Next, letter B is the marking of the polarity. The terminal shall be identified according to the requirements of IEC 600952 or of IEC 60095 Part 4. Letter C is the fastening of the battery. Where batteries are fastened to the vehicle by means of integral parts, this shall be in compliance with the requirements of IEC 60095 Part 2 and 60095 Part 4. IEC 60169 Radio Frequency Connectors. IEC 60169 serves as a generic specification providing the basis for the sectional standard which apply to individual connector types, establishes uniform concepts and procedures concerning terminology, standard rating, and characteristics. testing and measuring procedures concerning electrical and mechanical properties, classification of connectors with regard to environmental testing procedures involving temperature, humidity, and vibration. Next is the IEC 60205, the calculation of the effective parameters of magnetic piece parts. IEC 60205, calculation of the effective parameters of magnetic piece parts. This specifies uniform rules for the calculations of the effective parameters of closed circuits of ferromagnetic materials. Next is the IEC 60216, electrical insulating materials. The IEC 60216 Part 1 test standard specifies the general aging condition and procedures to be used for deriving thermal endurance properties and provides guidance in using the detailed instructions and guidelines in other part of the standard. Although originally developed for use with electrical insulating materials and simple combination of such materials, the procedures are considered of more general applicability and are commonly used in evaluations of materials not intended for use as electrical insulation. Next is the IEC 60446, Basic Safety Principle for Man-Machine Interface Marking and Identification. Basic and The IEC 60446, Basic and Safety Principle for Man-Machine Interface Marking and Identification. The identification of equipment terminals, conductor terminations, and conductors, also standard published by the IEC or the International Electrotechnical Commission, that define basic safety principles for identifying electrical conductors by colors or numerals, for example, in electricity distribution wiring. The standard permits following colors for identifying conductors. We have black, brown, red, orange, yellow, green, blue, violet, gray, white, pink, and turquoise. The color green and yellow on their own are only permitted where, where confusion with the coloring of the green-yellow protective conductor is unlikely. Combinations of the above colors are permitted, but green and yellow should not be used in any of these combinations other than as a green-yellow for the protective conductor. Neutral or midpoint conductor. If a circuit includes a neutral or midpoint conductor, then it should be identified by a light blue color. Light blue is the color used to identify intrinsically safe conductors and must not be used for any other type of conductor. Next is the AC phase conductors. The preferred colors for AC phase conductors are, this is for three-phase. For line 1, we have brown. Line 2, we have black. Line 3, we have green. And for a single phase, we have brown. Next is the protective conductor. The color combination green-yellow, as I've said earlier, is always and exclusively used to identify the protective conductor. On any 15 mm length of the conductor, one of these two colors should be covered between 30% and 70% of the area, and the other the remaining area. Next is the protective earth and neutral or PEN conductor. Insulated PNN conductors, combined protective earth plus neutral in TNC system, should be marked either green-yellow along their entire length with light blue markings at their ends, or light blue along their entire length with green-yellow markings at the ends. The cable have cross-section of 16 mm squared or 5 AWG or greater. Next is for the United States, Canada, and Japan. The three countries, United States, Canada, and Japan, are mentioned in a note in the standard for using different colors. white or natural gray for mid-wire or natural neutral conductor instead of light blue, and green for the protective conductor instead of green-yellow. Marking, where conductors are in addition identified by letters and numbers, then the letters to be used come from Latin character set. The number must be written in Arabic numerals. Digits 6 and 9 must be underlined, and a few symbols like addition and subtraction can be used. Green and yellow conductors must not be marked. Next is the 60601 Product Safety Standards for Medical Devices. IEC 60601 is a series of technical standards for the safety and essential performance of medical electrical equipment, published by the International Electrotechnical Commission. First published in 1977 and regularly updated and restructured as of 2011. It consists of a general standard, about 10 collateral standards, and about 80 particular standards. The general standard IEC 60601-Part 1, the medical electric equipment, the general requirements for basic safety and essential performance, gives the general requirements of the series of standards. 60601 is widely accepted benchmark for medical electrical equipment, and compliance with IEC 60601 Part 1 has become a requirement for commercialization of electrical medical equipment in many countries. Many companies view compliance with IEC 60601 Part 1 as a requirement for most markets. This standard does not assure effectiveness of medical device. In the US, evidence of effectiveness is required by the FDA and confirmed through either a pre-market approval (PMA) or similarity to predicate device via 510(k) per pre-market notification. uh, Collateral and particular standards. Requirements of 60601 Part 1 may be overridden or bypassed by specific language in the standard for a particular product. Collateral standards numbered 60601 Part 1-X define the requirements for certain aspects of safety performance. Example, the electromagnetic disturbance, IEC 60601 Part 1-2, or protection for diagnostic use of X-ray, IEC 60601-1-3. Particular standards numbered 60601-2X define the requirements for specific products or specific measurements built into products, like the MR scanners, IEC 60601-2-33, or electroencephalograms, IEC 60601-226. Collaterals and particulars may have their own revisions which are different from the general standard. For example, IEC 60601-1-9 for environmental conscious design of medical electrical equipment, published in July 2007, is a collateral standard to IEC 60601 Part 1 and has been developed drawing the extensive practical experience of Philips Medical Systems and Siemens Healthineers. The Part 9 standard asks manufacturers of the medical device to consider the environmental impacts of their device throughout the product's entire life cycle and to minimize this where possible. The standard also requires that the manufacturer provide information to the user on how to use the product in the most environmentally sensitive way. The USA, Canada, Japan, Austria, and New Zealand have not yet transition dates for their national version of this latest edition 60601 Part 1, but the national version published to date do contain the requirements to also confirm with IEC 60601 Part 1-9. However, The European version EN 60601-1 2006 requires compliance with the new IEC 60601-1-9 collateral standard by September 2009. The 60601 certification process has been criticized for its complexity, the cost, and the business risks it raises. This has been more particularly concerned during the transition to the third edition due to the indefinite adoption of schedule of the new revision. Next is the IEC 61511 functional safety. IEC 61511 is a technical standard which set out practices in the engineering of systems that ensures the safety of an industrial process through the use of instrumentations. Such a system are referred to as system instrumented system. The title of the standard is Functional Safety Instrumented System for the Process Industry Sector. History. In 1998, the IEC published a document, IEC 6158, entitled The Functional Safety of Electrical, Electronic, Programmable Electronic Safety-Related System. This document sets the standard for safety-related system design of hardware and software. IEC 61508 is generic functional safety standard providing the framework and core requirements for sector-specific standard. These sector-specific standards have been released during the IEC 61508 framework, the IEC 61511, the IEC 61513, and lastly the IEC 62061. IEC 61511 provides good engineering practices for the application of safety instrumented system in the process sector. The IEC 61511 reference the IEC 61508, as I've said now, for many items such as manufacturers of hardware and instruments, and so INC cannot be fully implemented without reference to IEC 61508. IEC 61511 is the process industry implementation of IEC 61508. Now the scope. The process industry sector includes many types now the scope. The process industry sector includes many types of manufacturing processes, such as refineries, petrochemical, chemical, pharmaceutical, pulp and paper, and power. The process sector standard does not cover nuclear power facilities or nuclear reactors. IEC 61511 covers the application of electrical, electronic, and programmable electronic equipment, while IEC 61511 does apply to equipment using pneumatic or hydraulic systems to manipulate final elements. The standard does not cover the design and implementation of pneumatic or hydraulic logic solvers. This standard defines the functional safety requirements established by IEC 61508 in process industry sector terminology. IEC 61511 focuses attention on one type of instrumented safety system used within the process sector, the safety instrumented system, which is the SIS. Now we go to the standard. IEC 61511 covers the design and management requirements for SIS throughout the entire safety life cycles. Its scopes includes initial concept, design, implementation, operation, and maintenance through decommissioning. Through to decommissioning, it starts in the earliest phase of project and continues through startup. It contains sections that cover modifications that come along after. after with maintenance activities and the eventual decommissioning activities. The standard consists of three parts: the framework, definition, system, hardware, and software requirements. Number two is the guidelines in the application of IEC 61511 Part 1. Number three, the last is the guidance for the determination of the required safety integrity levels. IEC 61511 requires a management system for identified SIS. An SIS is composed of a separate and independent combination of sensors, logic solvers, final elements, and support systems that are designed and managed to achieve a specified safety integrity level. An SIS might implement one or more safety instrument functions, which are designed and implemented to address a specific process hazard or hazardous event. The SIS management system should define how an owner or an operator intends to assess, design, engineer, verify, install, commission, validate, operate, maintain, and continuously improve their SIS. The essential role of the various personnel assigned responsibility for the SIS should be defined and procedures developed as necessary to support the consistent execution of their responsibilities.
IEC 60228. This is the IEC's international standard on conductors of insulated cables. It defines a set of standard wires for cross-sectional areas. So, dito sa table, makikita natin yung cross-sectional areas niya and yung equivalent wiring. So, this also refers to the flexibility and thermal effects, including the temperature of a conductor. So, meron tayong apat na class, which is class 1 solid conductor, class 2 stranded conductor intended for fixed installation, class 5 flexible conductor, and then yung class 6, which is a very flexible conductor. The nominal cross-sectional area for standard conductors, including the class 2 minimum number of strands required to make particular conductor size, and then class 5 and 6, yung maximum diameter of any component strand of the conductor. So the maximum permissible resistance of each conductor size, class, and type. Next is the IEC 60269 para sa mga low voltage fuses. This is a group of engineering specifications for low voltage power fuses. The 4 volumes of the standards include basic requirements, fuses for commercial and industrial applications, fuses for residential applications, and fuses for semiconductor device protection. So the IEC standard improves the interchangeability of the fuses in global trade by combining multiple national standards. All of these fuses evaluated to satisfy the IEC standards will have comparable time current properties, which makes the design and maintenance easier. So, yung application nito is ng mga fuses is makikita natin in 2-digit code. First, yung first letter niya kapag letter A siya, ibig sabihin yung fuse natin is for short circuit protection, which is kailangan pa rin natin mag-provide ng overload protection. Next, kapag yung first letter naman ng fuse natin is G, it is intended to operate even with currents as low as those that cause it to blow in 1 hour. So, ito yung mga fuses na kino-consider natin as general purpose para sa protection ng mga wires natin. And then, yung second letter naman natin, ito yung nag-i-indicate ng type of equipment or system na kailangan nating maprotektahan. So, dito makikita nyo yung mga types ng equipment and then yung letter na nag-symbolize sa kanila. For example, yung TR for transformer and then PV for solar photovoltaic arrays. And then, meron din tayong mga iba't ibang test na nire-recommend para sa mga fuses within the IEC 60269. Kasama dito yung test ng temperature rise and power dissipation, non-fusing and fusing test, verification of rated current test, overload test, and then verification of time current characteristics and gates test. Next is the IEC 60282 for high voltage fuses. So this part of IEC 60282 is ina-apply naman siya para sa lahat ng types of high voltage current limiting fuses designed for use outdoors and indoors on alternating current systems of 50 Hz and 60 Hz with the rated voltage exceeding 1000 volts. So, meron tayong iba't ibang klase ng fuse na nakapaloob dito sa standard natin. For example is DC fuse, AC fuse, and then yung mga fuse or link type cartridge fuses. And then meron din tayong mga testing as per IEC 60282 such as ratings and characteristics para dito sa mga applicable fuses natin, para sa mga particular fuse link types and yung applications nila, and para din sa design, construction, and performance nila. Of course, pag-identify din ng mga markings, dimensions, and yung magiging fastening nila sa mga batteries. Then we have the IEC 60309 is of course an international standards from the IEC for plugs, socket outlets, and couplers for industrial purposes. So meron tayong highest requirement in terms of voltage which is allowed by the standard na 690 volts DC or AC. Para naman sa highest current is 250 amperes. Highest frequency is 500 Hz and yung temperature range niya is between negative 25 degrees Celsius to 40 degrees Celsius. So, proceeding sa IEC 60309-1. So, this specifies general functional and safety requirements for any form of industrial high current power connector. Then, IEC 60309-2 specifies a range of main power connectors with circular housings and different numbers and arrangement of pins for different applications. So, meron tayong mga connectors na pinoproduce in different variants. And kaya ganun yung pinoproduce natin so that meron tayong plug in this certain type na ginagamit lang din natin siya sa socket with the same type. And dahil doon, meron tayong iba't ibang current ratings such as 16 ampere, 2 ampere, 63 ampere, and then yung 125 na distinguished by different diameters of circular housings. For IEC 60309-3, it deals with connectors for use in explosive gas environments but was withdrawn in 1998. And then for IEC 60309-4, ito naman is concern niya yung mga switch, socket outlets, and yung connector interlocks. For a background, in UK or United Kingdom, yung standard nila dati na ginagamit is BS 4040 1968. Pero ngayon, pinalitan na siya ng European equivalent which is yung EN 60309 1999. So, sa UK, yung mga plugs na nakapaloob dito is tinatawag as commando, CEE Industrial, CEE Form, or simply CEE. Next is the color identification. So, yung mga plugs natin and sockets natin are identified siya by different colors. Alam naman natin na around the world, yung or dito sa Philippines, yung tinatawag natin na 110 volt is ang color niya yellow. And then for 230 volts, meron tayong blue. 400 volts is red. And then yung black natin, 500 volts is, ito naman yung mga kadalasan na nakakita natin sa mga ship. And then, so kung makikita natin sa table, halos lahat from purple to black is yung frequency range niya is 50 to 60 Hz. And then nagva-vary lang yung voltage ranges nila. Yung green naman, ito naman yung mga iba-iba yung voltages niya, pero yung frequency range niya is greater than 60 to 500 Hz. And then yung gray naman is siya yung different dito sa lahat ng to or hindi siya pasok doon sa color coding natin. Next, for the IEC 60598, yung luminaires naman natin. So 60598-1 specifies general requirements for luminaires, incorporating electrical light sources for operation from supply voltages up to 1,000 volts. So, yung requirements na to and yung mga related test of IEC 60598-1, ang kino-cover niya is yung classification, marking, mechanical construction, electrical construction, and then yung photobiological safety. So, in addition to these general requirements, meron din tayong series of standards na specific to different type and intended para sa mga lighting and luminaires. So, itong mga standard na to is nagpo-fall under the safety requirements found in the EU Low Voltage Directive 2014/35/EU. And then for IEC 60598-2, ito namang part na to is nag-identify naman siya ng specific requirements for different types of lightnings and luminaires or group of luminaires on supply voltages not exceeding to 1,000 volt. So, publish naman to para sa mga manufacturers para ma-ensure natin na yung specific standards ay ginagamit nila habang nagde-develop ng regulatory compliance plan. Then we have here the list of EN/IEC 60598-2 standards, which have 14 different parts. Lastly, we have the IEC 60898, or yung electrical accessories for circuit breakers for overcurrent protection for household and similar installations. Alam naman natin na yung circuit breakers are automatically operated electrical switches na dinedesign para protektahan yung isang electrical circuit from damage caused by currents na nangyayari dahil sa overload or short circuit. So, meron tayong IEC standard, which is yung 60898-1 para siya sa mga AC operation. So, itong standard na to is nag-a-apply for alternating current, kasama na dito yung mga open circuit breakers operating at 50 Hz, 60 Hz, with rated voltage not exceeding 440 volts, and then rated current not exceeding 125 ampere, and rated short circuit capacity not exceeding 25,000 amperes. For IEC 60898-2, ito naman yung mga circuit breakers for AC and DC operations. So this part of the standard, in addition dun sa -1 natin, is meron din siyang DC voltage suitable for the operation with direct current not exceeding 220 volts for single pole. Also, suitable siya for operation with AC and not exceeding 440 volts for bipolar circuit breakers. And it contains additional requirements para sa mga single pole and two pole circuit breakers with a short circuit capacity not exceeding 125 amperes and 10,000 amperes. Then IEC 60898-3, ito naman yung mga circuit breakers for DC operation which are intended para naman protektahan yung mga wiring ng buildings and similar applications against overcurrent. Ito naman is designed siya para sa use and maintenance by untrained persons. The IEC 60898 standard does not apply to circuit breakers that are listed below. So, yung una is yung mga circuit breaker para protektahan yung mga motors, and then yung mga circuit breaker whose current setting can be adjusted within user access. And again, we are Group 6. And thank you for listening. We hope that you learned something from us.